Right. No, I don't think we should wait, yeah, because he does have a technical problem. So, okay, let's start with the new Jamboard first on page 3, yeah. Now, I will come to this. Will do this new thing, which is memorization, and then we'll go back to the graph so that you see the connection. Yeah? But right now, it will seem that we're doing something new, right? Something new, right? And we're going to talk about nice numbers, right? Nice numbers, yeah.
Okay.
Now, take your calculator and confirm with me that here's 30 degree. Yeah? Now, sine 30 degree will be a nice number, but cosine is not. Please confirm that for me.
Yeah.
Yeah. So now, AMAT makes a big deal about nice number. So they don't see nice as nice. Yeah. So for example, half, right? Half was your sine 30 just now. They don't think of it as nice or not nice. They think of it as exact. So to us, it's a nice number. To them, it's exact. Exact is very, very, like they make a big deal out of it, and they always do that. So they like a number. It's very different from EMAT. EMAT don't care too much about exact numbers, right? If it is possible for you to give, for example, 1/3, to me, this is nice. 1/3 can also be 0.34, for example, estimate. Now, EMAT wouldn't mind doing this at all. Wouldn't mind at all, right? Unless they say must be exact. They almost never say that. But for AMAT will very, 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 very strongly prefer this. Very, very strongly. That's how AMAT works, yeah? So I'm going to give you the exact version, the nice number version of cosine 30, right? So I'm going to tell you this, right? That's the nice, that's the exact version. And then would you please try in your calculator, is this the result that cosine 30 give you? Please give it a try. Okay, so they are exactly the same, yeah? Am I correct? That 0.866 is exactly the same as half root 3.
Okay.
All right. Have you tried the half root 3? Okay, please just confirm that it is the same or not the same. Okay, you can compare up and down. You use up and down to compare. Are they exactly the same? Yeah. They are, yeah, they are. All right, good. Now, the moment you know this, yeah, the moment that you know cosine 30 is half root 3 in your class, then from then on, cosine 30 shall not be 0.866 anymore. Shall not be in AMAT. In AMAT. Okay, it will always be half root 3, no matter whether they say or please make your number exact or not, no matter whether they say that. It is automatically half root 3 the preference. Okay. And that's how I want to condition you and Aditya and Ines to recognize the nice numbers, right? Because they won't actually tell you. Most of the time, after a while, they don't tell you. Remember, guys, this is supposed to be nice, okay? You gotta find the nice one. They won't tell you after. Okay, so I will give you 2 ways to memorize, and you can choose because then you keep using them, right? So now let me give you the first one. So the first one is you memorize the degree. So this will be 0, 45, 60, and 90. Now this is AMAT's way of telling you those angle will always give you a nice number, no matter sine, cosine, or tangent. No matter, it will always be a nice number, right? Always be a nice number. So ding 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 0, 1. Simple, right? For sine, yeah. We'll start from sine first. Now half root 2, half root 3. Okay. Now this is something additional. Look, obviously root 1 is just 1. You would agree with me, yeah? obviously, yeah. So root 1 is just 1, meaning, okay, right, okay. Meaning I'm just putting it there to help you memorize. What do I mean? See, half, root 1, root 2, root 3, something like that. Just to help you memorize, right? The 0 and 1 should be easy enough to no need help. So one more time, the nice number is available for sine 0, sine 30, sine 45, sine 60, and sine 90. Now, are we lagging somehow? I think we're probably lagging the Jamboard. Okay, yeah, but you can see them. You can see them. So you can see them. Right, that's fine. Okay, yeah. Now, in this method, memorizing the sine is enough. And then I will show you that cosine is just the reverse. Okay, so what do I mean by that? Okay, so in the cosine, watch, it will be the exact reverse of sine. And like that, look. Okay, just the exact reverse. So not that difficult to memorize. I will draw the graph just to re-emphasize. So I'm drawing a very big sine graph. Remember, scale, 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 big long, right? Remember, yeah? So helpful points. I usually do two helpful points because the helpful points here are obvious to me, but you can do 5. So like that. So I'm just going to draw the first part only, right? The reason is because we're just talking about 0 to 90 for now, right? So here's your 90, right? And I'm going to draw the cosine graph also. So the cosine graph, the helpful points are here, here, and here, right? So that will be your cosine graph there, like, okay? Ding, 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 ding. I hope it makes sense to you. This is cosine, and this is sine. So I hope it makes sense to you to see that sine goes up like that and cosine goes down the reverse. See, sine goes up like that in 90 degree and cosine goes down like that in reverse. And in 45, we mentioned already, they meet at the same place. That means they have the same value, and there you go. All right, or connected to what we learned just now. So far, so good. Now, I haven't shown you the tangent graph. I'll show you later, but the memorization first. Now, if you know, that's good. If you don't, I'll tell you. Tangent is always equal to the sine of that guy and the cosine of that guy. So tangent 30, for example, is equal to sine 30 over cosine 30 if you have to. If you have to split it that way, you can always do that. Okay, yeah? So you don't need to memorize tangent. For example, tangent 0 degree is 0 over 1. Well, that's very easy. What's 0 over 1?
No.
Sorry, what is that? Sorry.
0.
0. Very good. So very easy. I'm checking on Aditya. Yes, right. And 1 over 0. What is 1 over 0 for 90 degree?
0 also.
No. Press your calculator. 1 over 0. What is that?
Math error.
Right. Now, math error means it's either positive infinity, whatever that means, or negative infinity. Right. So this will be infinity, or they know it as math error or undefined, whichever it is. Right. So 1 over 0 is not 0. That's a common mistake. Right. Now, another thing which is very easy with tangent is 45, of course, because this over that. You don't have to calculate, right? It's something over that something that will be equal to. Oh, you don't calculate. No, you don't calculate. No. A very weird number, understand, over himself is going to be always equal to 1. Very good. 1. So tangent 45 is what data I draw for you. You'll see. Now, the other two is also not very difficult. For example, I'll give you 60, right? It's a weird number, half root 3, nice, but weird. Over half, okay, the root 1 is just have to help you. The half cancel each other, right? So the answer is root 3. Well, there we go. And the other guy, half over half root 3, the half cancel each other, 1 over root 3. Never mind that the cert tells you got to change this guy. I know the cert will tell you, rationalize this guy. I mean, for now, don't care. Just memorize how 1 over root 3. Not very difficult. Okay? Okay, and voila, this is our basic memorization. We are memorizing the exact guys. One more time. If it is sine 20, will it be a nice number?
No.
Very good. If it is sine 44, not gonna be a nice number. If it is sine 91, not gonna be a nice number. By sine 0, 30, 45, 60, and 90, it is going to be a nice number. Right. Now, this is your first way of memorizing. I am going to ask you, when you're ready, I'm going to erase this table and you're going to repeat that. Okay? All right. When you're ready, I will erase and then you will try. Tell me when. Remember, just memorize the sign, right? Only that, and the angles, and probably with this help. That's about it. That's about all you need to memorize.
Okay.
Are you ready?
Yeah.
I will erase everything, and then you can start. Well, give it a try. On the same spot, please. Very good. Officially, the infinity, it is infinity, yeah, but officially they write down as NA or undefined, right? And then I like your sign bracket. This shows you that you know it's not sign, it's sign of something always. I like it, right? Sign of zeros. You cannot just write sign as something. I cannot just write some angle. Very good. And everything is correct. Just remember to not write the root one at the final answer. If you write this as the middle answer, there is no problem at all. Really no problem. Okay, yeah? Right. So there are a few options if you like this table method. Most of the time, if you like this table method, I will say to you something like this. You're going to write this down immediately at the start of exam. It just takes 1 minute for you, right? Doesn't seem to be much of a problem. And then you don't have to remember. You just have to use it in exam. You won't forget also. That's the beauty or the good thing about it. Okay, yeah? Now, let me show you the other method first before we go to all the complicated stuff, right? So your teacher most likely will do something else to help you memorize because it is important. So he will tell you memorize using 2 triangles. So there you go. 2 triangles. Notice that the triangle is 90 degrees. There are 2 triangles. Okay, the second triangle is a 45 degree and 45 degree. You would agree with me that's isosceles?
Yeah.
The second triangle, the first triangle is 30 degree and 60 degree. There you go. We cover 30, 45, and 60 in these 2 triangles. Where's the 0 and where's the 90? Well, you memorize them by yourself. Okay, so how does the triangle method works? You have to memorize a few other things. Okay, so it goes like that. You have to memorize that this is 1 and 1. Okay, I'm sorry, I have to write it as blank. 1 and 1, and this one is 1 and 2. They don't explain to you why, but you should memorize it that way. Okay. Now, the blue number, you don't have to memorize. For example, I'm going to write something here. I don't have to memorize the number here because I can work it out. What should it be? Pythagoras, 1 square plus 1 square becomes? Pythagoras, so, yes. Oh, Aditya, okay, I can see you now. Kyoko, can you hear me? Is it lagging now? Is it somehow lagging? Hello. All right. Now, what would be this number if we use the Pythagoras? Right? Square root. Yeah, correct. I think because it's lagging, the I cannot hear. Yeah. So root 2 from the Pythagoras. Yeah. Now I'm gonna go to Aditya first. Aditya, can you hear me loud and clear?
Yep.
All right. Now, if it is lagging, Aditya, or if you have a further problem, please use the
No,
fonts here.
I don't think I would, because like I dismantled the whole.
Guys, that there were chocolate chips inside.
There were chocolate chips inside the router.
Yeah, my cousin did that.
Wow. Wonderful that you discovered the chocolate chips inside the router. That will be my favorite phrase for today, okay? Chocolate chips inside the router. All right, good. Now, glad to have you here. Very quickly, get you up to speed, Aditya. I am veering away from the graph for a while in order to help you memorize. There are a few things to memorize because AMath has a big thing with exact numbers. Okay, so look at this table very quickly, Kyoko. I'm going to revise with Aditya. You have to memorize that these angles are going to give you nice numbers. I mean, they look kind of nice compared to your calculator. If you press sine 30 or cosine 30 or tangent 30, for example. Now, quickly, Aditya, take your calculator, confirm with me. Cosine 30 in your calculator is not a nice number. Correct?
Yeah.
All right, I'm seeing you.
Oh.
Right. I think the cal camera you can, yeah, right. Okay, wonderful. Now, could you please confirm that this relatively nice number is actually the number your calculator is giving you for cosine 30? So please try that very quickly. Okay, so are they the same number, the cosine 30 and the half root 3 here? Are they the same number?
No.
You press the half root 3, please. Press the half root 3, and then you can do a comparison.
Oh, half.
Mm-hmm.
Wait, what?
Let me see your calculator. Let me see your calculator. Quickly.
Are we on the Jamboard? Oh.
We are on the Jamboard, but it is going to be page 3. Oh, yeah, you haven't seen the Jamboard. Yeah, page 3, please. Aditya, can I have a confirmation? Okay, so is this the same number, the exact same number with cosine 30? You're muted, yeah, so don't be muted. Difficult to communicate.
Yeah, it's the exact same number.
All right. Now, here's the thing about AMath, very different from EMath. In EMath, you give him 0.866, very happy. EMath will accept that. In AMath, the moment they teach you that cosine 30 is this nice number, relatively, half root 3, you can no longer go back to 0.866, right? So the calculator kind of surprisingly doesn't help you there. It's going to be cosine 30 equals to that. Cosine 45 equals to all this number in the Jamboard. Okay, don't worry, you don't have to write that down right now. No need, no need. But you need to know, you ought to memorize this the moment they give you. They will never go back to the ugly number anymore. Now, here's the implication, Keiko. If they ask you for tangent 45, what are you supposed to write? Tangent 45? 1, very good. But Aditya, if they ask you for tangent 44, What do you write? A nice number or not a nice number?
It's not a very nice number.
Not a very nice number, and they will accept that in A math because 44 doesn't give you a nice number, no matter sine, cosine, or tangent. But the moment they tell you, give me sine 60, what should you give? Sine 60, what should you give them, Aditya?
Sine half root 3.
Yes, which, let me remind you, the calculator is not helping much here. The calculator can probably help you confirm, but not give you the half root 3. So they give you the table to memorize stuff lah. All right. Now, I taught Keiko how to memorize. We'll come back to that later. I'm teaching Keiko the second method of memorization. You're just in time. Okay. So you're going to look at the second method of memorization. Look at this, everybody. I want you to draw this triangle and this triangle with all the angles and all the sides. Okay. Okay. Now you're going to do that after you say ready. Meaning to say, I'm going to erase this triangle and then you're going to try. All right. Keiko and Aditya, tell me when you are ready. And then I'm going to erase.
Okay.
Yeah.
Okay, let's wait for Aditya. Okay, I'm going to erase 2 triangles for both of you. Please give it a try. Very good, Keiko. You should be drawing a better triangle. Very good. Yes, I like it. Very, very good. Okay. Very good, Aditya. Very good triangle, Keiko. Good start. Yes. All right. Good, Aditya. You got the correct one. Let's wait for Keiko. All right. Now, actually, Aditya corrected my mistake. Yeah. So my mistake is this. I wrote this 2. It's a memorization. And then I wrote this as 1. The Jamboard is very laggy. Yeah, I think the Jamboard is kind of lagging because it doesn't show. Yeah. 1, 1, and 1. Okay. Right. So is the Jamboard showing the 2, 1, and 1, 1, Aditya, for you? These numbers, is it showing?
Yeah, yeah.
All right, very good. So Aditya corrected me. I put this as 1. That's wrong. It should be 1, the short guy. So thank you very much, Aditya. Now, the rest no longer need to memorize. Now, please tell me why I don't need to memorize that this is root 2. I can get it. I don't need to memorize this is root 3. I can get it somehow. How did I do that, Aditya and Kyoko?
Pythagoras theorem.
Very good. For both of them, right? So this root 2 will be root 1 square plus 1 square. This root 3 will be, well, root 2 square minus 1 square. You get your root 3. Whether you want to memorize or not, that is up to you. But I'm just telling you, oh, well, you can get it from Pythagoras. Clear, Aditya?
Yeah.
All right, please add your root 3 and root 2, and then we're ready to use them. Now, this is supposed to be a replacement for table. So if you memorize the table, you don't need the 2 triangles, vice versa. Let's try, okay? Now, sine 30, well, 1 over 2. Correct? Because sine 30 is opposite over adjacent. 1, well, opposite over hypotenuse. So, right? So your SOHCAHTOA. Your SOHCAHTOA. Now, let's try using the triangle for our benefit, yeah? So we don't have to memorize. For example, a sine 45, how do you use sine 45, Kyoko? It's going to be who over who? Kyoko? Remember sine 45, right? So, right. So sine 45, the opposite over the hypotenuse. So 1 over root 2, right? So here I get from triangle, sine 45 is a nice number called 1 over root 2. Wait a minute. 1 over root 2 is not the same as the table here. Can anybody tell me, are they the same thing or not?
No.
Aditya, then use your calculator to see for yourself whether 1 over root 2 is the same as
Oh, wait,
half.
yeah.
Okay, can you tell me why it is the same? Because they don't look the same. I understand. But why are they the same? Actually, why are they the same?
Gut feeling.
That is you. Okay, please confirm first using your calculator. There is a reason for that. Kyoko, do you remember why they are the same? Any idea, people? So Kyoko, do you know? Why is half 1 over root 2 equals to that? No? Kyoko, no idea?
No.
Okay, let me show you, right? Okay, so the topic cert, let me confirm first. Aditya, did you learn cert in AMAT? Have you?
Yeah.
Okay, and how about you, Kyoko? Have you learned cert? Okay, so refreshing your cert, people, 1 over root 2, and then they kind of say in the cert, okay, I don't like the cert at the bottom. I don't like the cert at the denominator. Do something about that. Okay, I'm going to do something about that. Equals to what happens to the denominator, Aditya?
It becomes 2.
And then on the top, you have root 2. Voila. 1 over root 2 times 1. Isn't it just 1? Right, this is just 1 here. All right, so 1 over 2 is equal to root 2 over 2. Well, there you go. You have it in the table. Okay, people?
Yeah.
All right, yeah, clear. So let's use the triangle for a few other things. So, okay, Kyoko, if I say, for example, cosine 60, then you must say, oh, cosine 60. Cosine 60 is going to be 1 over 2. Something like that. And Aditya, you can just use your triangle with your finger because I can follow. You can also do that, Kyoko, just use your finger. Yeah. So let's practice using triangle. Okay, what does a triangle say about cosine 30? What over what? Cosine 30, what over what? Remember, cosine is adjacent over hypotenuse. So this is your 30. Your fingers are not moving very gently, right? So Aditya, right? Cosine 30, okay. And then what over what? Ka, adjacent over hypotenuse. Very good, very good. It's root 3 over 2, right? Root 3 over 2. Very good. Oh, okay. I see what your finger is pointing, Jacob. So I need. So it's root 3 over 2 according to the table. Is that the same thing?
Yeah.
Very good, very good. Okay, now try again. Okay, let's try sine 60, please. That guy over that guy. Very good. So Aditya, root 3 over 2 also. Wait. In the graph, in the table, cosine 30 is equal to sine 60. No surprises there. Very good. Last one. Tangent 45. Tangent 45, please. Very good, Aditya. 1 over 1. Kyoko, yes, 1 over 1. Yeah. So according to the table, also 1. Okay. Now, Kyoko, you have the benefit of trying both methods. Start with one method first, and then maybe as you develop expertise, you may want to switch to the other method. That's totally up to you. All right. But you make a choice. You're going to do the table method right now, or you're going to do the triangle method for today. Next time, maybe you can change. Which one would you choose?
The table.
The table method. Now, Aditya, I'm going to tell you something about the table method. The table method doesn't require you to memorize a lot of things. In fact, the table method just requires you to memorize the sign. The reason is very simple, because the cosine is the total opposite of sine. So this will be 1, 0, and this will be half root 3, half root 2, and half root 1. Okay? Then the tangent will be sine over cosine, always true for everything, right? So what do we have as tangent 0? 0 over 1 is what, Aditya?
What?
One more time. For me, tangent is going to be sine over cosine. Okay? Always
Okay.
like that. Tangent is sine over cosine in anything and everything. So we don't have to memorize the tangent value. We just have to look at the sine value over the cosine value. What is 0 over 1?
0 over 1 is 0.
Nothing divided by 1 equals to? Nothing divided by 1?
Nothing.
Very good. Nothing divided by 2?
Nothing.
Nothing divided by 1 million?
Nothing.
Very good. Nothing divided by minus 2?
Nothing.
Still nothing. So 0 divided by 1 is 0. And I think it's more helpful to use logic instead of using the numbers. The numbers doesn't always tell the reason. Now, what is this over there? The same guy over the same guy. What would that be?
1.
Very good, right? No need to memorize. Now, how about 1 divided by nothing? This is a bit weird. So what is 1 divided by nothing?
Nothing.
No. Interestingly, your calculator will say differently. Your calculator will say math error. There is a sign for infinity, right? What you write is this is n instead. I'm not going to explain that, but please, 1 over nothing turns out to be not nothing. It is not. It is not. Turns out to be infinity, a super big number. Explanation follows later. Now, Kyoko, please tell me, what is this guy over that guy?
Root 3.
Very good. Now, Aditya, can you see that? Half root 3 divided by half root 1. You know what? The half simply cancels. The root 1 is just 1. So half root 3 divided by half root 1 is just root 3. If that makes sense.
Yeah, I get it.
By the same token here, we'll just get 1 over root 3. Okay, 1 over root 3. Yeah, so I've demonstrated to you the cosine and tangent part of the graph. It's more like it's worked out for us instead of being memorized. You do have to memorize the sine and the angle. Now, Kyoko, you have made your choice. Huh? You choose table for today. Aditya, make your choice.
Table also.
All right, so I'm going to erase everything one more time. Both of you make your own table and you're going to use that for the remaining of today. Yeah, you can change only, tomorrow, for example. When you say ready, I will erase. Are you ready, Aditya?
Yes.
All right. Okay. So Keiko, you're going to repeat one more time, and therefore, hopefully, you'll get it forever lah. Hopefully, yeah. So erase. Good. Okay. Please repeat the table. Very good, Kyoko. Okay. Very good. Yep. Excellent, Kyoko. Excellent, as expected. Yeah. Okay, wonderful. Yeah, wonderful. Excellent. Okay. Excellent. Both of you are correct. Now, use this table. You don't have to repeat this every time in a question. In exam, I suggest to you, Kyoko and Aditya, write this table for once and forever be useful for you throughout the exam. Okay, no need to recall during the question. Just spend 1 minute doing this. You're going to be very, very happy. Okay, now I'm going to give you two things. Now we start to talk about all the complicated stuff surrounding this. The table is easy. The table is the AMAT obsession with exact numbers. Exact number being nice number. 30 is nice. Half is nice. Cosine 45. 45 is nice. Half root 2 is nice. No longer will they accept decimals for this guy. Now, I am going to gonna show you something, right? I think I should show you this first, right? Okay, so sine A plus minus B equals to sine A cosine B plus minus sine B cosine A. Right, so this comes out of nowhere, people. This comes out of nowhere, and you don't have to memorize. You have to know that they exist. This thing exists, and you have to know how to use it. Now, this one, you don't need to memorize. One more time, you don't need to, but you have to know how to use them. So I'm going to explain what this means. I'll give you an example. For example, 75 degree. Notice that 75 degree is not on the table. Yeah, no, it is not. Now, sine 75. And then suddenly they tell you, give me a nice number. Their word is going to be, give me an exact number for sine 75. Wait a minute. Is that even possible? Sine 75. Well, only if you use this to supplement your table. Now watch. Okay. Now, even though this doesn't make sense, comes out of nowhere, Aditya, but tell me, follow this formula. Tell me, what am I supposed to write here? What am I supposed to write here? Follow the formula. Aditya, can you hear me?
Yes.
So sine A plus B in this case, yeah, this will be sine 45 plus 30. So what would this guy be? Yeah, this will be.
So sine 45.
All right, good.
Cosine
And then
30.
Okay, very good.
Plus
Plus in this
sine
case,
30
and then
cosine 45.
all right. All this complication, like very complicated. I would like you to press the calculator for this one. Just press it. Just press it. Press the calculator for this one. It will not give you a nice number because calculator cannot give you a nice number. Press the calculator. Kyoko also, yeah. You'll probably need the bracket, I think. Aditya, I'm not sure. Do you need the bracket?
Yeah.
You can try without, but I'm not sure that that's okay. I'm not sure. Yeah? Now, of course, people, this will give us not nice number. I understand. It will not. Right? So, however, compare the result with when you press the calculator sine 75. Now, press sine 75. What happens? Are they the same answer?
Yeah.
Right? Aditya. So Aditya have the same answer. So Kyoko, I think you typed the wrong thing. Just check first. This will be sine 45 cosine 30. Sine 30. I'm so sorry. I did the wrong thing. This is cosine 45. That's cosine 45. Still the same thing though. Cosine 45. The cosine is the mistake. Yeah, the cosine is the mistake. The sine 30 is supposed to be cosine 30. Okay, there you go. All right. Equal. All right. So is that the same thing, Kyoko? With
Yeah.
sine 75. Very good.
Yeah.
Now, they are so obsessed with exact numbers that they're going to give you 2 marks for doing this. One more time, huh? Instead of asking you, just press the calculator, okay, and be done with it. Sine 75 equals to 0.966, right? Instead of doing that in AMAT, they're going to give you 2 marks in order to do this long thing. So tell me from the table, what is sine 45, Aditya?
Sine 45 is half root 2.
Good. And then cosine 30, what is it? I'm so sorry. Let's go.
Cosine 30 is half root 3.
All right. So I'm going to do this. Huh? So this is going to be half root 2 over 2. I'm preferring the times half root 3 over 2. And then Kyoko, sine 30 will be?
Half
And then cosine 45?
root and half root 2.
Good, root 2. And then what happens to the first fraction, Aditya? What do you write here? Remembering your cert a little bit, yeah? Root 2 times root 3 will be?
Root 6.
Root 6, and then over 4, no surprises. The second fraction, Kyoko? Half times root 2 over 2 will be?
And 1/4 root 2.
Right, 1 over root 2, right there. And then to combine, we're just going to write this, plus that, simple cert over 4. This, they give you 2 marks. Instead of, in EMATH, for example, they give you 1 mark for this. They are so obsessed with exactness, they give you 1 more mark for, kind of a little bit more effort. Right? Now, press your calculator. Please confirm that root 6 plus root 2 over 4 is that ugly number. Please do that. Aditya and Kyoko, press the calculator. Aditya, are you going to press the calculator? Don't keep us waiting.
Yeah.
Right. All right, please don't keep us waiting. Right. Okay. It is the same. And as you see, we just make something magical with this newfound formula, and we use the table, and voila, we have a nice. Okay, Aditya, please do that immediately. Don't keep us waiting. We won't finish at this rate. Yeah. Okay, so is it the same?
Yeah.
All right. Now, 75 is not in the table. So if it is in the table, they don't give you extra marks. But when it is not on the table and you have to do fancy stuff like this, at least they give you more marks. This is, again, AMAT's obsession with nice numbers, right? So they kind of want nice numbers even outside the table. Now, let me ask you something. Sine 15, both of you, yeah? Now, 15 degree is not on the table, but they can and they will ask you for exact number. How is that possible? How is that possible?
Take sine 45 degrees minus 30 degrees.
Very good. This newfound formula out of nowhere gives you a minus option, and the change is here also. Okay, so sine 15 will become sine 45 minus 30. And then it will become basically root 6 over 4 minus root 2 over 4. I'm just taking from the previous guy, right? Just this one, no? Right? Equals to root 6 minus root 2 over 4. Okay, people, try to confirm with your calculator, do the ugly number, and confirm whether it's the same as this thing, right? Sine 15 will be ugly number. Okay, Aditya, please show me your calculator so I can follow. So, yeah.
The same.
They are the same, right? Okay, so Aditya, what are you going to do after sine 15? Very good. Yeah, it's not going to be plus, yeah, Aditya, obviously, because the plus will not be, the plus will be 475, right? Okay, there you go. Right, are they the same? All right, so there go another obsession of a math for the exact number. All right, sine 15, and there will be this one. Okay, now the formula come out of nowhere, no need to memorize, but you do know that there is such formula and you do need to use it. Now, any questions so far?
I have a question.
Yes, Kyoko.
Is the dot is multiplication, right?
Yes, that's the shorthand for multiplication. Correct.
Okay.
Now, any question from you, Aditya?
No.
All right. Now, I did say to Kyoko from the start, things get abstract before that get very clear. So this might seem to be not heading anywhere, but if I don't go through you this at the start, at the holiday tuition, then in class, there is a chance that it becomes much more confusing. That's why we're doing it. You might not see the goal yet. Bear with me. This is abstract. And if I'm rushing you, it's because we do have to save our time, right? Okay. Now, any question, Aditya? Are you sure? No question?
No question.
All right. So now, the formula comes out of nowhere, and you are to use it. I'm going to give you another formula. Before that, I'm going to teach you how to kind of memorize the formula so that you feel comfortable. It's not a requirement. It is to make you more comfortable. Now look at how I do it. Right? So sine A plus minus B is equal to, using shorthand, SACB, sine A cosine B plus minus cosine A sine B. Right? Pure memorization. I'm just using a shorthand to make it hopefully slightly easier. Right? Sine A cosine B plus minus cosine A sine B lah. Okay, just to hopefully help us a bit, because I have to give you this guy, cosine A plus minus B, same thing. They are not the same, right? So this will be cosine A cosine B, something weird, minus plus sine A sine B. Okay. So the plus minus means if I have cosine 75, right? Let's say I use cosine 75 again, and then I will now use cosine 45 plus 30. I'm sorry. This will be equal to cosine 45 cosine 30 minus sine 45 sine 30. There you go. Okay. Any question on this new formula? Any question on the new formula? Aditya, okay? Kyoko, okay?
Yeah.
Yeah.
Okay. Now try cosine 15. I'm getting you used for the calculator. I'm getting you used on that. So 15. 15 will be what? 15 will be cosine 45 minus 30, right? And then this will be a plus, right? Do the calculator for confirmation, and then do the search. You got to practice your search also. All these things are going to come in very quickly. Right. Do the calculator and then do the search. Aditya, are you okay?
Yeah.
Aditya, are you going to do the calculator or write on the paper? Okay. For you, Kyoko, the formula is weird, yeah? I mean, the formula doesn't make sense. It's a formula. So plus minus, minus plus. So if there's a minus here, this becomes a plus. It's like that. It's like that.
Oh, okay.
Okay. Aditya, do you have your calculator or your paper writing? Aditya? Can you hear me, Aditya? Aditya, this is the 5th time I'm calling you. Any response? Aditya, this is the 6th time I'm calling you. Any response? So Aditya, I lost you and then you're back, yeah? Can you hear me? You're muted, yeah?
Yes, hi.
All right. Okay. So I've been calling you for the 8th time, but turns out that maybe it's an iPhone problem.
Yeah, I couldn't hear anything, so I thought something was wrong, so I left.
Definitely. What's going on here? Yeah? What's going on? Turn on the video, please.
Yep.
Right. Okay. And also, you have to mute one of the mics. If not, you'll echo. You'll echo. Right. Okay. Okay, those are the nice numbers, Keiko. And then please try with the calculator, just to show that you're correct.
All right. Okay.
All right. Please quickly try, Aditya. Very quickly, yeah. Very quickly.
What were we doing again?
This guy, the obsession with exact numbers, right? The obsession with exact number, they ask you cosine 15. 15 is not on the table. So I give you a new formula, right? Cosine 45 minus 30, that's how we're going to deal with 15. And then we apply the formula and then do the search. You got to practice your search for this one also. Practice your search, press your calculator, see what is correct. Are you clear, Aditya? Please tell me if you don't not clear, yeah?
I'm not clear.
All right. So write down cosine 15 quickly in your paper. Follow me quickly.
Okay. All right.
Not on the table. Oh no, oh no. Split it to cosine 45 minus 30. Equals to cosine 45 minus 30. And then use the formula, right? The formula here for cosine A minus B will be cosine A cosine B plus sine A sine B. And that's why you write this, no? Cosine 45 cosine 30 plus sine 45 sine 30. It comes from this out of nowhere formula. So please write that down. Very good. Very good. And then you can use your table and your search skill. So you need the table now and your search skill also. Please give it a try. Now, Keiko, you have confirmed with your calculator, yeah? Any questions so far? Okay. Right. Okay, so be very clear, yeah, Aditya, yeah? You cannot do it this way, yeah? Right, so you're not doing cosine 45 minus cosine 30. That's not how it works. Cosine 15 is not cosine 45 minus cosine 30. If that is true, I don't need to give you the formula. I wish it was that easy. I wish. It is not. You're mistaken. Yeah. You should be doing that long guy, which is again.
Yeah, I wrote the equal sign there accidentally because like the like the first equal sign was there.
Right. Yeah, you're using the table. Yeah. That's not a minus. That's a times. Right. All right. Very good. Right. And then you get a plus sign. Yeah. Okay. Very good. Using the table. times half. And then you apply your surd, and then hopefully you get a shorter number. And voila, the AMAT obsession. Yeah, the calculator is not going to help you here, yeah, because the AMAT, yeah, ask for nice numbers. Yeah, keeping it nice. Yep, keeping it nice. Yep. Very good. Okay, and then the calculator can help you confirm whether this kind of nice number is going to be correct. So you're going to press your calculator for cosine 15, and then you're going to press this surd combination also. Quickly.
Yeah, it's the same.
All right. Right here, the obsession of AMAT. Kyoko, any question?
No.
Aditya, any question?
No.
Right. I'm leaving the formula here because you'll be using it from time to time. I'm going to give you two formulas that came out of nowhere, right? Sine 2a equals to 2 sine a cosine a. Some people prefer to see this as just this. So cosine 2a is a plus a, isn't it? Right? So it'll be sine a cosine a plus cosine a sine a. That would be the 2 sine a cosine a. If I confuse you just now, never mind. Just memorize this as a different formula. You'll be using it anyway, right? This comes out of nowhere. It doesn't make sense at all. This kind of thing doesn't make sense, but it'll work. Sine 2a, it will be equals to there you go. This thing also comes out of nowhere, and voila. Okay. So you have now the minimum foundation for AMAT trigonometry. The table of exact number, the formula, and the graph. The graph is what I teach you in the first section. The graph will almost be the important thing for understanding. Your teacher will present it like not that way, right? Now you'll see what I mean soon enough, right? So for example, sine 121 degree, for example. Do you press the calculator or you make effort for nice numbers? Which one, Aditya?
Nice numbers?
No, because 121 cannot be gotten from the table and the formula. Never mind the graph for now, yeah? Why do I say that? Because I only have this. I cannot form 121 with a plus b or a minus b or 2a, right? I cannot. 121 will be an ugly number and totally acceptable in AMAT. However, 120 is different. 120. So think carefully, yeah? It's not on the table. Do we make extra effort for exact number or not, Kyoko?
Yes.
Now, which formula we'll be using? Because you know what? It's not going to be on the table, right? Which formula?
A.
You can use A. Give it a try. Do your A. I will tell you, Aditya and Kyoko, you can actually use other formula. I mean, I'm referring to either A or C, yeah? Never mind the cosine formula. You can actually maybe use C also. Maybe. We're combining the table and the formula. I want you to think like this. Now, finally, we can use our brain and think a little bit. Which one should I use? The A or the C, right? Which one? You decide. I want to see some action.
C.
then feel free to try C and let's see what happens. Right? The A will work, yeah, but the C I believe will work also. All right, I see your point, people. It's 2 times 60. How very interesting. All right, so if it is since 2 times 60, how do you use the formula? Excellent. Yes, very good. 2 sine 60, cosine 60. Excellent, Aditya. And excellent, I think, Kyoko also. Let's see. All right, time to use the table. Wonderful, Aditya. Wonderful. Yeah, very good, both of you. Very, very good. All right, Aditya, I would like you to test using your calculator, yeah, to find out whether you're correct or not. Kyoko, you can simplify a bit more, yeah, a bit more.
Yeah, it's wrong.
Now, Aditya, the good news is this, the only mistake is the last step. Well, I would say the last 2 steps. So you are doing very well until the last 2 steps. Please find your mistake. Kyoko, you can simplify even more. Oh, you can, definitely you can, right? And you should. Oh, there you go. Very good. Aditya, this is your mistake. See, our mistake is hard. I want you to develop that mistake. Add that skill, that mistake. Okay. Now, Kyoko, while waiting, yeah. Nice or not nice, right? So cosine 25, nice or not nice.
Wait, does that 2 only apply to sine 60?
But yeah, no. The 2 applies to sine 60 and cosine 60, but together taken, it's 2 sine 60, cosine 60. So it does apply only to sine or only to cosine because it's times. I'm not sure whether it makes sense, right? Not sure whether it makes sense to you, right? Okay. Now for you, Keiko, the question for these 2 things is nice or not nice, exact or not exact. If it is exact, you have to do something. If not exact, that means you press calculator.
It is 130, right?
130 for the bottom one. The top one is 135. Nice or not nice? Exact or not exact? So what do you think, Aditya? Your new number, is it correct? Using the calculator, yeah?
Yeah, it's correct.
But you need to test it against sine 20, yeah? You don't test it against your own working. You test it against the question. The question is sine 20. 120. Is sine 20 your final answer? Most excellent. Most excellent. So you're correct, yeah? Now, a little bit more because I don't think we have time left, yeah? So these 2 things, the question, the implied question is the same. Nice or not nice? Put effort or just press calculator? These 2 things, cosine 135 and sine 130. Put effort or simply press calculator? Which one will it be?
Cosine 135 can make nice number.
All right. Show me how do you do it. Show me how you do it. Right. How about you, Kyoko? Have you decided what to do? You can, well, okay, you can erase this. Now, if you're stuck, tell me, because that's the point of this practice, right? What am I supposed to do? Is this going to be exact? So let's see what formula you'll be deciding on, Aditya. Ah, looks good to me. Okay, good choice of formula, Kyoko also. Okay, Aditya. So again, although the formula doesn't make sense, you have to apply it correctly here. So if this is a plus, strangely enough, it will be a minus here. Strangely enough, yeah. Plus, minus.
Oh,
So yeah, the formula works that way, right? So yeah. Both of you are doing well. Very good. Okay, wonderful. Please confirm with calculator, Keiko. All right. Notice that your answer is not a negative number, but the numbers are correct. Correct or not, Aditya?
yeah.
You're missing the negative, and this tells you that there is a small mistake, and you must find it. You must find your own mistake, right? Very good. Now, Kyoko, have you confirmed using calculator? Wonderful, Aditya, you're correct.
Yeah.
Yeah, so you're correct. Now, confirming using calculator will prevent you from a lot of mistakes in the pressure of exam. That's why I keep telling you, confirm using calculator. The ugly number is useful. Use your calculator. Use your calculator. Excellent, both of you and Aditya, for finding your mistake. I don't mind you doing mistake, yeah. I mind if you cannot find mistake. Now, sine 130. What do you think, people? Aditya, Kyoko, nice number or just press calculator?
Calculator.
Calculator. Okay. What do you think, Aditya? Same. And I agree with you. There is no combination possible for 130. There's no combination. Now, I'm going to show you. Oh my goodness, we still have 20 more minutes. I see the question. I see the thing wrong. I'm going to show you something weird. Okay, something weird. Yeah. First thing first, I'm going to expand this guy. I'm going to expand this guy. So this guy has options, right? Just like the A has option, plus or minus, I'll give you. Plus or minus, I'll give you. The fourth guy also has options. Again, this formula doesn't make sense. One, we just have to know how to use them, right? Okay, I'm going to show you something complicated that hopefully you can accept, right? So something complicated. Now, the cosine 2a can become this option or this option or this option. Right. Now, sine, a weird number, 22.5 degree. Okay. Look at the formula, look at the table, look at the graph if you want to. Put effort for nice number or press the calculator. What do you think, Aditya and Kyoko? What do
Wait,
you
is that a
think?
22.5?
It is a very weird number, 22.5. A very weird number. What do you think? Put effort or press calculator?
Calculator.
All right, Kyoko say calculator. Aditya?
I agree.
Okay, I'm about to do something weird, which means I'm not going to press the calculator. I don't have a calculator with me anyway. Okay, I am going to use this thing for some strange reason and this thing for some strange reason. I'm going to rewrite them just to be clear. So I'm going to put effort here, basically. Cosine 2a equals to 1 minus 2 sine square A. Even weirder than that, I'm going to do this. Cosine 45 degree. What does 45 degree have to do with this? Well, it's because of this. Now, before I continue, people, am I writing any sense? What am I doing here? Do you understand, Aditya? Do you understand, Kyoko?
Not really.
Okay, Kyoko?
Yeah.
What do you see, Kyoko? Why am I writing all this nonsense?
Yeah. Okay, yeah, I get
What,
it. Okay.
what do you see,
Yes.
Aditya? Tell me, what do you see?
The number inside the bracket is 2A. And
Yeah.
22.5 is like A, because 22.5 is half of 45.
Very good. So I put 45. That's my target. Because I realized after some experience, 22.5, yeah, this 45 like lah. Something like that. Something like that. Okay. So is this not going to be easy? I applied the formula, then I have to do some gymnastics, some algebra. Please watch me how I do it first before you continue, okay? Before you continue. Now, this will be my root 2 over 2. Please notice that in the middle of working, I prefer the mixed fraction form rather than this nice form. This is the nicest form for presentation. This is the nicest form for working. Okay, root 2 over 2. Now, again, watch what I'm going to do. Okay, some gymnastics in algebra. 2 sine square 22.5. The problem is this guy, right? Because I want this guy, right? So what do? I will put my 2 sine square 22.5 on the left-hand side. I'll have 1 minus root 2 over 2, correct? And then use some pencil, half times half. Because I don't want to rewrite things, I can just do this even in exam. I just can root that. So silent, something like that. Okay? This is not going to be a nice number, okay? But this is... Actually, I don't know whether your cert can handle this. Can your cert handle this? Oh no. Okay, have you done the double cert? Did you do a double cert, Kyoko, in your cert?
What is a double cert? I don't think so.
Inside the cert, another cert, and have you handled this?
I don't think so.
This sometimes happen in exam. Only in exam though. That's the annoying thing. Aditya, did you handle double cert in your cert topic?
I think there were some challenge questions with double search, but not in a test or anything.
Crazy. All right. So I'm not going to teach you cert today, okay? That's just too much. I'm just going to ask you to press calculator, sine 22.5, ugly number, right? And just use the calculator to confirm whether my answer is correct or not. This double cert. Your calculator can handle double cert. It's just that they will give you a ugly number also. Just confirm whether my working is correct first. Please try that.
Wait, is this sine or cos?
It is sine. And surprisingly, I'm using cosine. But why? Because I need the A, right? I need the A. I only have the formula this with that. I cannot use this formula. Do you know why I cannot use this formula, Kyoko? I cannot use C. That's the other thing I want to talk about. I can't. Do you know why, Aditya? Okay, Aditya, you confirm, right? Am I correct first?
Yes.
Yeah. The double cert your calculation. So I'm not making this up, Aditya and Kyoko. Now, the other question I want to ask is, how come I don't use C? You need to know this, okay? I cannot use C. You cannot use C. I have to use D. Super weird. Why? Why? Why can't I use C? Looks simple, what? Any opinions, people? Why can't I use C? Am I supposed to use C? Maybe you can use C.
No idea.
All right, Kyoko. Now I'm going to show you very clearly so that you know this is not making our life difficult, right? Okay, it's not. So your 22.5 must be the A, right? Because we need the 45 to be the 2A. That one makes sense, right?
Yeah.
Okay, so obviously sine 45 is on the table. We are very happy with that. Obviously, sine 22.5 is what we want. Well, here is the problem. Here is the problem. This is the problem. That is the problem. Do you understand what I mean by cosine 22.5 is a problem?
No.
Okay, Aditya, Kyoko, do you see why it might be a problem?
No.
I will show you. I will show you. Remember, if you can deal with double cert, yeah, this will give you a nice number in the end. But I'm not going to teach you the double cert for now, right? It sometimes happens. It sometimes happens. So this is too advanced for today. Too advanced, right? Now I'm going to show you why C will give us big problems that we cannot solve. So sine 45 degree equals to 2 sine 22.5 degree. Very happy with that. Cosine 22.5 degree. You're not worried about that. Now, sine 45 will be your half root 2. So root 2 over 2, happy with that, equals to 2. My sine 22.5, I'm going to leave it there. And what can I do with my cosine 22.5 degree? Can I do anything, Aditya?
I have no idea.
Okay, because I need to find sine 22.5, right? So I need to do something with cosine 22.5. Can I do anything with cosine 22.5, Kyoko?
No.
I also have no idea, Aditya and Kyoko, because I don't know what to do with it. That's the problem. They want sine 22.5 me. Okay, I'll give you this, but I cannot do anything with that. I am stuck. Ta-da, finish. C cannot use, look. C cannot use. I have to do the complicated route using this formula instead. Again, am I making the problem up or do you see the problem? Do you now see the problem, Kyoko?
Yeah, I see.
Aditya, do you see the problem? If you don't, please tell me. Yeah?
I do.
All right. And we cannot use option C because of that. Okay.
I have a question.
Yes, please.
So how do we know when to use C or D?
C or D. Right. Okay. Very simple. I'll give you an example. Let's call it this way. Yeah? C is less flexible than D. D is actually very flexible, even though we don't like D. We don't like the square. So let me show you something that C can handle. Let me show you something. For example, they ask you for sine. Actually, he can only handle sine 120. Yeah, that's how inflexible C can handle. So sine 120, you will write down as C 2 sine 60 cosine 60. Make sense, Aditya?
Yeah.
And voila, I suppose that's all he can handle for our purpose tonight. For our purpose, it is very useful at other places. For sine 120, 120 is not on the table. 2 times 60. Okay, let's use. Okay. That's it.
Okay.
If I want to sine 60, do I go and make the effort to sine 30 cosine 30? Do I do that, Kyoko? No, yeah, because it is on the table, right? It is on the table. Although the formula would work, it is on the table. The formula is useless that way. If I do, I want sine 90, do I do sine 45 cosine 45? Do I do that, Aditya?
No.
Because the table already has 90. You see how limited the usefulness of C for today. Do you see that? Very limited.
Yeah.
D is more flexible, even though we kind of don't like how it looks, right? Some people feel like that until until O level. Yeah, I just don't like B. So that's how it feels. Okay. Any other question? It is a very good question, Aditya. Yeah? Any other question, Aditya and Kyoko?
No.
No.
Okay. Okay. Now for our last practice for today, I'm going to go back to the graph because the graph will feature a lot tomorrow. Now follow me in Jamboard page 4. I will draw the graph of tangent. Surprise, surprise, the graph of tangent is going to be much, much easier.
Easier.
Okay.
I like
How much?
after the class, like it was so weird.
Super, 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 super easy. I promise you, Aditya, I will make your life easy. Okay. Today, at least once, I will make your life easy. Okay. So following the same thing, yeah, like that. Following the same thing. Right. Look at the x-axis and the y-axis. Please follow the same thing. Now, Kyoko, I'm going to invite you to do the same thing. All right. So go ahead, making some space for you. There. Okay, I want to see some nice scaling. I want to see you act like a professional. Some nice scaling, some straight x-axis. Some nice division. Yeah, very nice, Kyoko. Very, very nice. Okay, some nice scaling. Aditya, very good. Yeah, very good, Kyoko. All right. And then the fourth one shall be long. Very good. Okay, being a professional here. Good. Very nice, Aditya. Okay, now the drawing is always the last. Remember, in the sine and cosine, I teach you do the axis nicely, do the scaling nicely, do the helpful points. Then your drawing is very much easier. Do not follow people who draw immediately because they have been drawing for maybe 5 to 10 years. Don't do that. I can draw immediately, but you're drawing this the first or second time. You have to do it professionally, I would say. Same thing with tangent. Now look at what I do first. Instead of drawing points, in tangent, I draw something a little bit different. I am going to draw 2 dotted lines. These 2 dotted lines are what we call asymptotes. Now you should know what is asymptote, yeah, Aditya, yeah? So follow me, please. I'm drawing the dotted line here and here at the precise location, please. Aditya, asymptotes, please. Don't keep me waiting. Quickly, yes, vertical dotted lines. Now for you, Kyoko, if this is the first time you hear asymptote, yeah? Asymptote is a line that the graph is not to touch, but the graph will approach very closely, but not to touch, okay? And this will be our guideline, precisely because we are not supposed to touch it. Now, Aditya, here's my promise. It will be very easy. Watch what I do, yeah? Boom, boom, boom. There you go. In the middle, please do that. Very good, Kyoko, for first time. Very good. Approaching the asymptote, but not touching, right? Your asymptote is wrong, Aditya. Yeah, your first asymptote is correct, Aditya. Your second one is wrong. The location is wrong. Your first one is correct. Yes. It's okay. First time. Be quick first. Be quick. You get the essence first, then you draw nicely. Very good. Okay, draw the middle guy, please. Like that. Approaching. Very good. Now watch me complete the graph. I will repeat this here. It is a repeat. Look, just like that. Look at that. Please try. Yeah, very good. I'm going to repeat the bottom guy here. Look at me. Like that. Like that. Yeah, it's not refreshing. Yeah, very good. Yeah. Very good. Yes, very good. Now I'll show you the full story. The full story looks like this because remember, every sine, cosine, and tangent graph are repetitions, right? So I'm repeating here just to show you the complete story, okay? Just to show you the complete story. What is my complete story? Well, the asymptote also exists here, right? And here. The asymptote here and here. And what is the complete story? Well, look at this complete story. Okay, same thing all over. Same thing all over. Same thing all over. Same thing all over. Do you understand what I'm saying, Kyoko and Aditya? It is so simple, tangent graph. Like that, like that, like that, like that, like that. In between the asymptotes. Just like that.
It doesn't touch in between, right?
Yeah, the asymptotes shall not be touched, but you shall approach them, so to speak. You shall approach them, but it shall never be touched. The teacher will be looking at for that. Not touching, but approaching. Do you understand what I'm saying, Aditya? The pattern of the tangent graph. It's very easy to understand, and frankly speaking, easy to draw if you draw the asymptote first. Okay. No questions on this?
No.
Nope.
Okay, Aditya, I'm going to ask you to do that one more time. Just one more time, just to get a feel of it. Kyoko, I'm going to ask you to erase when you're ready, and later on, do one more time, and then we shall call it a day. Remember, do it as professionals. The drawing always comes last. Do helpful things first. Okay. Excellent scaling, Aditya. Very good. Short, 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 long. Right? Short, 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 and then the long one. Very good. Wonderful. The asymptote, please. Very good. At position 270 and at position 90. Very good. Now you're ready to draw. If you like, draw the middle guy first. Always the easiest. You can do that. Yeah, you can break it to 2. Looks good to me. All right. Very good. Very good, Aditya. Did we make it easier than the class?
Yep.
Very good. As promised, this should be slightly faster and slightly easier than the sine and cosine. Very good, Kyoko. Now, any question at this point? Kyoko?
No.
All right, Aditya. Good. Now we have covered almost all the basics such that we can finally understand what's the question asking. I'm going to show you the questions tomorrow. For today, good job. No homeworks, and I will see you tomorrow at 1:30. Yeah?
All right.
Now, there is a chance. Sorry, I forgot to tell you this. I'm currently at Batam, right? Now, the reason is because I didn't plan to be at Batam, but I have to extend my passport. My passport cannot be extended in Singapore, so I have to make an urgent trip to Batam. Now, why am I telling you this? Because tomorrow there is a chance I will be called to finish up the passport, the goal of me in Batam. And if that happens, our first session might be only 1 hour. So from 1:30 to 2:30. And then we have to extend the second session. We have to do that a little bit so I can finish my goal here. Would that be okay, Aditya and Kyoko?
I'm not coming tomorrow.
Oh, yeah. You told me. Oh, you told me that. Oh, you told me that. Okay, understand, Kyoko. How about you, Aditya?
Sure. I mean, yeah.
All right. Do you have to do the projects tomorrow?
On Wednesday. So I'll let you know the time because I think they're planning for 12, but I haven't checked my phone in like an hour and 30 minutes. So I'll let you know.
All right.
12 on Wednesday. So.
Right. Try to avoid the tuition time if possible, yeah? Because I did say that. Try your best, yeah? Okay. All right. Good job. And I will see you either tomorrow or on Wednesday, Kyoko. Yeah. All right. Bye-bye.
Bye-bye.